Hello, everybody. It's me, Rich Andre. Now I'm going to be talking about the numbers in electrical engineering for today's video. So, if you have taken any sort of science class, okay, in your whole entire life, you probably are already very familiar with science. Oh, this is too thick. Let me just zoom out. You probably are already familiar with scientific notations, right? We can just search up any particular scientific notation. For example, Avogadro's number. As you can see here, okay, it's a very sort of big number, and it uses an exponent of 23. Okay. Now, my main point in mentioning scientific notations is for you to gain a sort of understanding how scientific notations differ from engineering notations. So, what is the main difference between these two? Well, the main difference is engineering notations, they use +3 or -3 exponents. Okay? Depending on what's convenient. But, okay, one thing I could say is that they're not as flexible as scientific notations. Because, of course, they have a 3 increment when it comes to exponents and notations, okay? So, given that information, we can try to apply it and make sense of it by finding an example. In which case, I could just find an example here in Khan Academy. Okay, so it says here it takes light 0.000333564.095 seconds to travel 10 kilometers in a vacuum. Let's convert this small number to engineering notation. It says here, find a decimal point. Okay, so let me just copy this. I'll do it myself. Okay. All right. All right. I think that's big enough. All right. So, if you can see here, this is apparently the time, okay, the time in seconds for it to take, the time in seconds it takes in order to, in order for light to travel, okay, okay, 10 kilometers. So, this is basically, okay, what we're going to work with. This is a pretty big number, despite it being very small, okay? So, in order for us to be a little bit more convenient, we use engineering notations, okay? in electrical engineering. So what we want to do is we want to take, okay, incremental steps by either hopping to the right or hopping to the left, depending on which is more fitting for the question, okay, for the problem at hand. What you want to do is you want to hop incrementally until you find, okay, until you can get two or three numbers, two or three non-zero numbers, okay? In which case, just three, okay? Just having 33 will do. So you can just hop four numbers here and then you can do this, you know? I mean, six numbers. You can just hop six numbers. Then you can add the decimal point there. So what happens is, instead of having this big number with all these zeros, you can just have this, you know? Okay? Now, we need an exponent for this 10. You just count how many points did you take in order to get to that point, get to 33, okay? So we can just count, you know. Just count 1, 2, 3, 4, 5, 6. Okay? So you get 6. Negative 6. Why negative instead of positive? Because there's a decimal point, okay? There's a decimal point there. Decimal point, okay? It means that these are decimals. So basically getting closer to 0. Okay? So that means it's negative. That means it's negative. So 10 to the negative 6 exponent. But if it were the other way around, okay, it's obviously going to be 10 to the negative, 10 to the positive 6 exponent. So that's how, okay, that's how engineers handle notations. Very unlike the scientific notations, which are a little bit more flexible, you know, when it comes to numbers. So we want to understand now, okay? We want to understand now what we call prefixes, okay? There are a lot of prefixes in electrical engineering. So we can start by listing down some tens that have exponents on them. That have exponents that either increase by 3 incrementally or negative 3. Okay? So we can have these prefixes. We can have, let's first write down the exponents, okay? By the way, all credits goes to Khan Academy for all of this information. So you can just search up Khan Academy and you can see this course for yourself. But I'm just explaining it, you know. So we have 10 to the 12th power, positive 12, okay? So we can get, okay, positive 12, 10 to the 9th power, 10 to the 6th power, 10 to the 3rd power, 10 to the 0 power. Then we can just go 10 to the 10 to the negative 3, 10 to the negative 6, 10 to the negative 12, oh no, 10 to the negative 12, 10 to the negative 9, sorry, 10 to the negative 12. There are three prefixes that we use in electrical engineering, which is, let's start with this. What does 10 to the 12 power mean? Okay, what does that denote? That is tera. Okay, that was what we call tera. Can be anything. Okay, like for example, a terabyte. Some things like that. So this is going to be so like a unit of measurement. It's just a unit of measurement. Okay, so this is what we call uh giga. 10 to the 9 power is giga. Then 10 to the 6 power is mega. 10 to the third power, okay? Oh, by the way, all of these are positives. The exponents are positives here. Kilo, okay? So this has no certain description, but this is going to be 10 to the negative 3 power. I believe this is micro, okay? This is micro. Uh, Hold on. This is actually milli, okay? Milli. We got micro, got nano, we got pico. So we can just, base like from here on, from here to here, we can just go like pico, kilometer, millimeter, micrometer, so on and so forth, like nanoseconds, that's those stuff, just those stuff. It's a little bit of an example we can use from these prefixes. So the numbers that they are abbreviated in are the following. Okay, we got tera, just T. Okay, G, M, 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 and then a small letter K for kilo. Just small letter K. It's not. That doesn't look like a small letter. Okay, uh, small letter K for kilo. Got millimeter. Okay, then we got mu here. Mu, the mu sign, okay? Not to be confused with M, okay? It's the mu sign. For micro, okay, we got nano, just N, just P. And that's basically it for the prefixes in electrical engineering, So this is how they handle numbers with the prefixes for unit measurement, and then engineering notations with our incremental and trees, whether positive or negative. So you can just search up this course, okay, which is on electrical engineering from Khan Academy. We could just search. We just look at the yeah, and we're right. We're right. So that's gonna be it for this video. It's just a little bit of introduction on how they handle numbers in electrical engineering, and it's gonna be it for this video. Thank you guys for watching. If you liked the video, if you learned anything, please give me a thumbs up. Please comment. Please subscribe. If you didn't like it, please give me your feedback, your honest feedback on the comment section below. Okay? I'll be sure to read it. I'll be sure to read it. Tune in, guys, for another video next time. Okay? Thank you very much for watching.